All right, today what we're doing is we're going to do group presentations on these 8 problems. Okay, I know some of them have double problems, so like page 9, number 3 and 4 will be one problem that you're going to do. So we're going to do these 8, okay? You're going to discuss the problems in your groups, and then you can select one person. I will give you one of these problems randomly, and then you can select one person in your group to present it. I will take a picture of your work on your paper, so it doesn't have to be on a separate sheet of paper like usually. You can just look at your homework if it's good enough. I'll take a picture of your work, and then you will actually record it on here. Okay, and you're presenting on the iPad. Questions?
So a 12 centimeter segment makes a 108-degree angle with a 16 centimeter segment. To the nearest tenth of a centimeter, find the third side of the triangle determined by the SAS information. So basically, I used the law of cosines, which is b squared plus a squared plus c squared minus 2ac cosine b. What? So this is angle B. This is side B. This is angle C, side C. Angle A, side A. So I put 108 in for B over here. And then I put, okay. So A squared is, oh my gosh. So I substituted all of this in here, and then I solved it, and I got B equals 22.77 or 22.8.
So number 6 is a continuation of number 5. Find the area of the triangle to the nearest square centimeter. So the area of a triangle is base times height divided by 2, so we have to find the height of the triangle. So I drew a right triangle right there, and this angle is 72 degrees because it's supplementary to 108. And then I used sine of 72 equals y over 16 to get y, and that comes out to be 15.2. And then I multiplied 15.2 by the base, which is 12, and divide that by 2, and I got 91.2.
Another way you could do this problem is, because this is a side angle side, we can use the area formula of 1/2 AB sine C, which the A's and the B's and the C's are different than we use in the law of cosine. The main idea here is that A and B are our two sides. So this would be 12. This would be 16. And then C is the angle included in those sides. So it would be sine 108. So you can actually do it pretty quickly there. 1/2 12 times 16 sine 108, and you get 91.2. So another way you can do it. And if you watch the first period video, they have another way you can do it using Harrow's formula.
Okay, so question 8 asks us to find all the solutions of t between 360 and 270. So we drew this circle here, and we saw that the only way to have cosine and sine equal is in a 45, 45, 90 triangle. So we drew that triangle here. But 45 is too small, and it's not in between 360 and 270, so we added 360 to 45 to get 405. To find the second answer, we saw that because here, the cosine and sine are both positive, the only other place that they're the same is in the third quadrant, where they're both negative. So we drew the second reference triangle here, and went from 45 round and added 180 to 45 to get 225, which is not big enough. So we then added 360 to 225 to get 585.
All right, so for 8, it's find all the solutions t between 360 and 720, and I got problem B. which was tangent t equals negative 4.3315. So what I did is I did negative or inverse tangent 4.3315, and that ended up equals 77 degrees. So, and negative 4.3315 in tangent, that would be in quadrants 2 and 4. So we did 77 degrees away from 180, which equals 103 degrees. And you have to add that to between 360 and 720, so we added 360 and got 463 degrees. And then we did the same, but with 360 degrees minus 77 degrees, we get 273 degrees. Add 360, and we ended up getting 643 degrees.
Okay, I got page 8, D, and I got cosine A equals cosine negative 110, and I took 360 minus 110 and got 250, which would be in the quadrant where cosine would also be negative, which is what you need. And then I also took 110, and that is also in the quadrant where cosine would be negative, and so your solutions would be 110 and 250.
I had page 9, number 2, and the question was, how long is the shadow cast on the ground, casted by the xy plane, by a pole that is 8 meters tall, given that the sun rays are parallel to the vector 5, 3, negative 2? Well, I started out by drawing the pole, which is 8 feet tall, and then you can see that the vector of the sun's rays are 5, 3, negative 2, so it creates that angle. But the pole's 8 feet tall, and so you can make that vector into negative 8, or 2012 negative 8 by just multiplying it by 4. So it creates the new vector, which is the shadow length. And then you have to square root the vector to find the Pythagorean theorem to find the other vector, or to find the length of the vector.
Okay.
And then you have 24.65 meters. And then you just have to find the other side b with Pythagorean theorem, and then you just square 8, and then add b squared, which equals 24.65, and then b squared equals 24.65 squared minus 8 squared, and then you get b equals 23.32 meters.
So we had number 3, a conical cup has a 10 centimeter diameter and a 12 centimeter deep, and is 12 centimeters deep. How much can this cup hold? We did an equation for the area of the circle, 1/3 pi r squared, and that gave us the area of 26.17. And we need to find the whole volume of the cone, so that's 1/3 area of the base times the height. When you multiply that all out, the area of the base times the height times 1/3, you will get the volume of 314.04 centimeters squared. And that is needed for number 4, continuation. Water in the cup is 6 centimeters deep. What percentage of the cup is filled? So as it's only halfway up of the cone, we figured that the radius would end up being 2.5 and being half of the original radius of 5. So when you do 2.5 squared times pi, you'll get 19.63. 1/3 of that is 6.54. 6.54 times the height of 6 will get you 39.24 centimeters squared. And when you divide that by 314.04, the original volume of the cone, you will get 12% of the cup is totally filled with the water.
C and E or C and D?
Okay, I'm doing number 7, C and E. And for C, it's 4u minus v, so I substituted in for u -2, 3, and 1. And I multiplied 4 times, 4 times -2, and I got -8. And then 4 times 3, and I got 12. And 4 times 1, and I got 4. And then I substituted in for v, the vectors 0, 1, and 2. And then I subtracted, or I multiplied out the negative into all the vectors 0, 1, and 2. And so you'd subtract -8 minus -0, which is -8, 12 minus 1, which is 11, and 12 minus 2, which is not 2, it's 10. Oh, 4, sorry. 4 minus 2, which is 2. So you get the vector -8, 11, and 2. And then E is U times V plus U times W. So I substituted in U and V, which is -2, 3, 1, and 0, 1, and 2. And so I multiplied both the vectors, 0 times -2, which you get 0, 3 times 1, which you get 3, and 1 times 2, which you get 2. And then I added those all together and got 5. And then for U times W, I substituted in the vector -2, 3, 1, and the vector 1, 2, -1. And I multiplied out, and I got -2 times 1, which is -2, 3 times 2, which is 6, and 1 times -1, which is -1. And I combined those all, and I got 4 minus 1, which equals 3. Added both the two and got 8.